Welcome to This Explainer. Today, we're executing what I like to call a tactical briefing. We are going to break down the optimal mathematical and chemical processes for baking lemon pepper salmon. Seriously, we aren't just talking about throwing a piece of fish into an oven and hoping for the best. We're looking at the precise science, the exact thermal parameters, and the fascinating biological realities behind a dish you probably thought was pretty simple.
Okay, let's just quickly breeze through today's agenda. Section 1 covers the protein matrix objective. Then Section 2 is Protocol Alpha, looking at chemical prep. Section 3 handles Protocol Beta, which is all about thermodynamics. Section 4 dives into the core temperature conflict. And finally, Section 5 wraps things up with a red team counter-analysis.
Right into Section 1, the protein matrix objective, fueling muscle synthesis.
So why are we engineering this specific protein matrix in the first place? Well, because a perfectly baked salmon fillet isn't just dinner, right? It's literally biological fuel. What we're looking at here is a high-quality protein matrix heavily packed with omega-3 fatty acids, and it's mathematically optimized for rapid muscle protein synthesis. If you've just finished a really heavy push, pull, or legs training block, this is absolutely the kind of dense, high-quality recovery fuel your body is actively searching for.
Now, keep the number 100 in your head for a second. That stands for 100 fluid ounces. You see, the light citrus and sodium profile of this specific lemon pepper dish is engineered to pair perfectly with high-volume, 100 fluid-ounce daily hydration protocols. It replenishes your sodium, while the citrus keeps your palate totally refreshed, which actually makes drinking all that water so much easier to maintain.
Moving right along to Section 2, Protocol Alpha, chemical prep, which is all about extracting moisture and building that matrix.
Before heat ever even touches the fish, we've got some chemistry that has to happen. Now, the term lemon pepper sounds like a basic seasoning, but it actually relies on some heavy-hitting chemical players. Specifically, we're talking about piperine, which is the active alkaloid found in black pepper. You know, salmon is an incredibly rich, fatty fish, and without a counteragent, it can taste overwhelmingly heavy. Piperine provides the exact sharp thermal heat needed to stand up to that rich lipid profile.
It's basically a chemical battle happening right there on your plate. On one side, we have the citric acid derived from fresh lemon zest, actively slicing right through those heavy salmon fats. And on the other side, the piperine is delivering a sharp thermal punch. It's this exact chemical pairing, acid and alkaloid, that makes the entire flavor profile work so incredibly well.
To actually achieve this matrix, we've got to follow a really strict order of operations. Step 1, you have to firmly pat the raw flesh dry with a paper towel. Total moisture extraction is key here. Only then do you move to Step 2, which is applying a light layer of olive oil to act as a binder. And finally, Step 3 is the heavy, even dusting of your chemical agents. That's your cracked pepper, fresh zest, kosher salt, and just a trace amount of garlic powder. But you might be wondering, why is Step 1 so absolutely critical?
Well, the crucial point here is that any leftover surface water acts as a direct enemy to our thermodynamics. Think about it. If water remains on the salmon, the oven's thermal energy doesn't roast the flesh. Instead, it gets hijacked and wasted entirely on evaporation. You basically end up steaming the fish in its own surface moisture instead of roasting it, and that will completely ruin the texture we're working so hard to build.
All right, Section 3, Protocol Beta, Thermodynamics. We are finding the mathematical sweet spot.
So, with the chemical matrix securely set, we must apply thermal energy with total precision. The data makes one thing absolutely clear. Temperature isn't just a suggestion, it's a structural control mechanism. If you bake at 350 degrees Fahrenheit, the energy transfer is way too slow, and you're going to end up with a softer, mushy texture. But if you blast it at 425 degrees, you risk rapidly drying out the edges before the core even has a chance to warm up. Therefore, exactly 400 degrees Fahrenheit is the mathematically optimal sweet spot. It gives you the exact perfect balance of speed and moisture retention.
And because we're operating at that optimal 400-degree mark, our execution timeline is incredibly tight. For a standard 1-inch thick fillet baked uncovered, you are looking at a very precise window. At exactly 12 minutes, you reach the minimum baking threshold. But 15 minutes, you've hit the absolute maximum. You are exposing the protein to this heat for only this exact 12 to 15-minute window, no more, no less.
Which brings us to Section 4, the core temperature conflict, pitting culinary aesthetics against federal law.
This is really the climax of our operation, where you face a pretty stark choice regarding the geometric center of your fillet. It's a direct collision of ideologies. On one side, you have the pursuit of culinary perfection, which demands a core temperature between 125 and 130 degrees. But on the other side, you have strict federal food safety compliance, which legally mandates 145 degrees. Let's break down why these two standards are completely at odds with each other.
First, the culinary standard. This is all about the sensory experience. To achieve that buttery, flaky texture that quite literally melts on the palate, professional kitchens universally accept that you must physically pull the salmon from the heat when the core registers between 125 and 130 degrees. After that, you rely on a 5-minute rest on the counter, allowing carryover cooking to gently push the temperature just a little bit higher.
Conversely, we have the federal standard. The USDA strictly mandates that all seafood must reach 145 degrees internally. And why? Well, because that temperature mathematically guarantees a 7-log reduction of pathogens and parasites. It is undeniably safe. However, there is a massive culinary compromise here. Pulling the salmon at 145 degrees will objectively result in a chalky, dry, and overcooked fillet. The protein matrix simply tightens up way too much and squeezes out all the moisture.
Now, Section 5. Red Team Counter-Analysis, looking at the biological realities.
Look, we can't champion the culinary standard without impartially evaluating the risks. And the red team notes some pretty harsh biological realities. Pulling salmon at 130 degrees objectively violates federal food safety standards. For immunocompromised individuals, this poses a severe, very real risk. Furthermore, if you're consuming improperly handled, non-sushi-grade salmon, you are absolutely opening yourself up to parasitic infections at these lower temperatures. We're talking about exposure to things like Diffulobothrium tapeworms. It's a genuine hazard, folks.
The rule here is incredibly simple. Unless your specific fillet was flash frozen at sea the exact moment it was caught, which is what actually kills those parasites, that dry, chalky 145-degree mark mandated by the USDA is literally the only way to mathematically guarantee absolute safety. If you don't know the origin and handling history of your fish, aiming for 130 degrees is a biological gamble.
But it's also worth acknowledging the origin of these preferences. The intense demand for medium rare to medium salmon isn't some universal historical truth. It's actually a preference heavily rooted in modern Western culinary aesthetics. We have essentially been trained to view 130 degrees as perfect, even when it completely contradicts fundamental safety algorithms.
So as we wrap up this explainer, you now have all the data. You understand the chemical prep, the precise 400-degree thermodynamics, and that intense conflict right at the core of the fillet. You are left with the ultimate operational dilemma. Do you embrace the dry, chalky reality of federal safety guarantees, or do you accept the biological hazards in the pursuit of absolute culinary artistry? Which standard will govern your kitchen tonight?